Today our topic is searching. Searching is a process of finding a particular element among several given elements. So the search is successful if the required element is found, otherwise the search is unsuccessful. There are two types of searching techniques. First one is linear search or sequential search, and second one is binary search. So today our topic is linear search or sequential search. Linear search is the simplest searching technique. It traverses the array sequentially to locate the required element. Means, say I want to search the number 76. So, it searches for an element by comparing it with each element of the array one by one. So, this is our array. It is an integer array. These are the index 0 to 6 and these are the elements. So, first compare, is 34 equal to 76? No. Then you have to check with the next element. Then compare 11 with 76. Is 11 equals to 76? No. In this way, you have to compare each and every element one by one sequentially. That's why this search is called sequential search. And when you get the element, this search returns what? This search returns the position of the element. Because we start comparing from the 0th element, so the position of 76 is 4. So it returns the position of the element, and that is linear search. So see the algorithm. Step 1, traverse the array. Step 2 is match the key element with the array. And if key element is found, return the index position of the array element. If key element is not found, then you have to return -1. When we can apply linear search algorithm? When no information is given about the array. See, I just want to search a particular element from an array. I am comparing with the first element, then with the second element. In this way, when we get the element, we just return the position. So when no information is given about the array, we can easily apply linear search algorithm. And when the given array is unsorted or the elements are unordered. Later we will learn binary search algorithm. In case of binary search, given array should be sorted. The elements of the array, in case of binary search, it should be sorted. But in case of linear search, if the given array is unsorted or the elements are unordered, we can easily apply linear search algorithm. When the list of data item is smaller, see, if the list of data item is bigger, means if there are huge number of data items, then you have to compare each and every element sequentially, and if there are huge number of data item, comparison takes more time. So if the list of data item is smaller, then linear search algorithm is more suitable. So write a C program to find an element using linear search. See the program. So this is our program. There is one integer array, int array 30, and these are all integer variables. Now what you have to do, you have to take the number of elements of the array, say it is n, and then start one for loop from 0 to less than n and take elements of the array, means each and every value of the array. Okay. Now what you have to do, you have to take the element which you want to search. So there is one printf statement, enter number to search, and it is a num. So I want to search num, this value, from the array ARR. Now I start another for loop for comparing each and every element of the array with num. So this loop starts from 0, I equals to 0, I less than n, I plus plus, and check whether our required element num is equals to the array element. Now when the value of I equals to n, means I have compared the whole array but I can't get the required element. Means what? When I less than n, this loop is true, but when I equals to n, means this loop is false. When I equals to n, then we can say the number is not present. Otherwise, if I get the element means if I get the matching element, if error I equals to num, equals to if I get our required element, then there is break. And after break, there is an if statement. If I equals to n, no, I get the element in between the array. So before the completion of the array. So come to the else part and print the index of the array. Means print the position where num is. So in this way linear search works. This is a very simple algorithm, very simple program. You can do it by your own. Pause this video, try to execute it by your own. Now run the program. Supply the number of elements, say I am giving 5. Supply the elements, first element, say it is 22, then 11, then 44, then 33, and then 55. I want to search 44. So the position is 2 because I start counting from 0. So 44 is in which position? 0, 1, 2. It is in second position of the array. Now we will learn efficiency of sequential searching. Efficiency means the time complexity analysis. In computer science, the time complexity is the computational complexity that describes the amount of time it takes to run an algorithm. In case of linear search, time complexity analysis is first the best case, means the best possible case. When, say this is our array, when I want to search 11, the first element of the array, then when the element being searched may be found at the first position. Say I want to search 11, I get 11 at the first position. In this case, the search terminates in success with just one comparison. See, only one comparison is required to search, and mainly time takes for comparison. And here only one comparison is required. So that is the best case. Thus, in the best case, linear search algorithm takes order of one operations. Now, worst case. In the worst possible case, the element being searched may be present at the last position or not present in the array at all. Means say I want to search 22. So first start comparing from the first element. Is this 22? No. Is this 22? No. In this way, you have to compare the whole array till we get your required element. Or say I want to search 99. So I have to compare the whole array till we get 99 and 99 is not present. So if the element being searched may be present at the last position or not present in the array at all, then also you have to compare the whole array. So that is the worst case. If the element is present but it is in the last position, the search terminates in success with any comparison. And if the element is not present at all, then the search terminates in failure with n comparison. Thus, in worst case, linear search algorithm takes order of n operations. So, time complexity of linear search algorithm is order of n, where n is the number of elements of this linear array. Now, time complexity means mainly it is the worst case time complexity. So, if in your exam, if it is asked that what is the time complexity of linear search, it is order of n, that is the worst case. So, in the best case, the element is present in the first position, and in the worst case, element is present at the last position or not present in your array. So, what is the average case? If the record is present somewhere in the search table, on an average, the number of comparison will be 1 plus 2 plus 3 till n, and the result is n plus 1 by 2. How we can get this? See, if the element is at first position, then it requires one comparison. But if the element is present in the second position, then it requires two comparison. If the element is present in the third position, then it requires three comparison. So if the element is at n position, then it requires n comparison. So total number of comparison is 1 plus 2 plus 3 plus 4, in this way n. So n into n plus 1 by 2. And total number of elements are in your array, say it is n. So n into n plus 1 by 2 divided by n. That is the average comparison. So the result is n plus 1 by 2. This one. So this is the case for average case. So in a nutshell, we can say that the average case occurs in the linear search algorithm when the items to be searched is in somewhere middle of the array. The best case occurs in the linear search algorithm when the item to be searched is in the starting of the array. The worst case occurs in the linear search algorithm when the item to be searched is in end of the array. If the desired record is present in the first position of the search table, then only one comparison is made. If the desired record is the last one or not present, then n comparison have to be made. If the record is present somewhere in the search table, on an average, the number of comparison will be n plus 1 by 2. So the worst case efficiency of the technique is order of n stands for order of execution. So these are your homework. Pause this video. Try to answer me this question in the comment section. Choose the correct option and try to answer me in the comment section what is the correct option. This is your programming assignment. Write a C program to find an element using linear search. For getting more and more updates, please subscribe, like and share my channel. That's all for today. Thank you.